Hello, sir. Welcome to this first podcast on powering India's semiconductor future. So, all those who are joining us online, please help me welcoming Mr. Chetan Arvind Patil, who is a senior product engineer at NXP USA, and he's currently situated in Arizona. So, with over 5 years of experience in semiconductor industry, in this day-to-day role, like what he's playing right now, he has worked on a lot of design about yield, quality, reliability, manufacturing, and assembly of new semiconductor products, catering to our mobile, automobile industry, and other domains. Mr. Chetan holds a master's in computer science engineering and, excuse me, yeah. So I was saying that Mr. Chetan is holding masters in computer science engineering, computer architecture and computer systems from Northwestern University, sorry, and Arizona State University. So Chetan sir, I now hand over to you to share with us about how we can go about the semiconductor and future of India in this.
Yes. Thank you, Rohit sir, for the introduction, and thank you to Professor Vella also for arranging this session. And I would be presenting a very broad topics about different points, touching on different points on semiconductor, and mainly also focusing on how the students' viewpoint, where India stands, and what opportunity lies, and how the products are developed, and then what the future looks like. So, to dive into this direct conversation of this particular talk which we are having today. So this is an outline I have for today's talk. I want to focus on, just a very view of semiconductor industry regarding how it looks from basic science point of view, applied science point of view, and then in terms of how the product development around the globe is and where India is standing in terms of both design and manufacturing. And then we will get down into the productization part, which is basically the ultimate goal of any semiconductor company in this world to design products, whether it's silicon chips, whether it is equipment, whether it is providing the materials. So all this are targeted product for a specific different types of companies. So we will also go in deep in detail on those parts. Then I will try to connect few points regarding how any individual or any person who is in a school environment like a pre-high school or a high school, and then going to join the undergrad or undergraduate course, or maybe is an undergrad student and transitioning towards graduate degree, then how that particular how the students on this background can apply different focus or skills areas to march towards a path which will lead them to a semiconductor career as such, whether it is business or whether it is doing a job or any domain possible. Then I will also then at the end of this talk I will try to focus on whether and try to help you uh, understand whether this is an industry for you, and if not, then how do you define whether it is or not an industry for you? Because there are so many options in terms of careers today, and you really need to understand where you are heading and why you should be heading. And similarly, in terms of semiconductor, which is right now being in a lot of focus for last 4 to 5 years, mainly because of the COVID-19 and how that impacted different production of consumer electronics or automotive electronics, and then the backlog in the market. So I will get into majority of details in these few slides which I have prepared. So to give you a very basic understanding about what semiconductor industry is, semiconductor industry is relying on one of the major components from periodic table. So in the slide deck, I have created a periodic table on the right side. And as we know, as we learn a lot about chemistry in our school education, right from secondary education up until high school, whether it is organic chemistry, inorganic chemistry, or any kind of basic chemistry. So one of the element which is very critical for semiconductor industry is silicon. and that is mainly used to build the building blocks of different products. And the reason silicon product is important is because of the properties it provides in terms of conductivities, in terms of electronic mobility, all of which we learn during our school time, like different ways to the electrons are moving and different properties a material has. So this is the reason why industry, when it started 40, 60 years back, or even before that, they started focusing on materials which are uh, being able to control properly, being able to control the flow of electrons, and you can hold the electrons so that you can create different type of devices like different resistor devices, different capacitor devices, different field effect transistor devices. So this is where the whole story began. And there are different alternatives also where the industry has started looking beyond silicon or the silicon material. They started combining different materials, let's say gallium nitride or gallium arsenide or silicon carbide. So these are different compound semiconductor which are available. So I won't go much into the details of compound semiconductor, but I wanted to give an overview of this technical field, which is called a semiconductor or semiconductor engineering, is actually started because of one element called as silicon, which eventually led to different kinds of products which we see today, whether it is your smartphone, whether the chips inside it, or whichever a black box with pins, any kind of devices you see is only because of this material. Now, uh, to understand more details about how the semiconductor product is developed, it is very important to go back a bit and see where this journey starts. Basically, the journey starts by mining and mining of the different raw material needed to create the elements needed for this specific silicon uh, property which we want to make. And then it goes through a different material process, which is, let's say, a proper turnkey coal mining sort of concept where you have different mining material, you're bringing the raw materials, and then you're making it through the reduction phase and purification phase. So as such, if you ask me whether the companies I work for right now, whether we do this, any of this part. So from this particular chain, we don't do A, we don't do B, we don't do C. There are companies which do D. So basically, the goal here is to say that to create a product which we call in a very generic term as silicon chip, you have to start from the mining of those raw materials, and then you have to convert into something called as ingot. This ingot is called as is a cylindrical shape. It is made up of all silicon material, and then it is sliced, and when it is sliced you get these kind of different wafers, and these wafers is where you try to print your design of all the resistors or the capacitors which are doing a specific function, but there is a broader process which is going inside that. And then you finally process this wafer into specific process steps. Let's say you put it through the different fabrication step of etching, lithography, and all those physics and chemistry related topics which come into those area. And then you go and convert this into a final finished good, which you then sell into the market. Let's say a single company like mine would sell, the company I work for, and then there are other companies which will sell their products, and then it will go into an end product, let's say a laptop. So if you have ever opened a laptop or a smartphone, you will see that there are different elements inside it. And those elements are nothing but called as chips. And these silicon chips is what the semiconductor industry is focused on, to provide you the end product in terms of functional parameters, functional properties, which can take your input and provide you an output which is very required in terms of day-to-day digitalization. For example, if you're playing a game, so you would need a processor which will do a lot of data manipulation. And for that, you would need a graphical processing unit. So those are the kind of products which the semiconductor industry works on. But to just give an over, so the reason I came up with this slide deck is to show that this is not just about applied. When you talk about basic and applied science, it's like basic science is mostly dealing with the physics, chemistry, or the mathematics part of it, and that is very core part of this whole industry. maybe I would say 40 to 50% of the work, and rest of them is just applying those knowledge and creating an end product called as semiconductor chips. Now, if you look at a broader perspective, what the semiconductor industry is about, so there are four pillars. So there is a market. Let's say there is a market called as smartphones. You want to build a smartphone, whether it is your Android phone or iOS phone or any kind of smartphone. But that market is designed to provide that particular solution. And then there are customers like would be me who will be buying the those smartphone, or you who would be buying that smartphone so that you can call, or you can have a you can read news, you can run different apps. And to enable these two things to for their customer, there are companies which are turning these ideas into products for silicon chips, and then sending it to different other companies who will then assemble them and then create an end product called, let's say, any company, for let's say Samsung will create their own product, Apple will create their own product. Similarly, there are different companies who will create their product, but they will take the silicon chips from different vendors or the companies which are primarily called as semiconductor companies. And the fourth pillar of this industry is employees. Employees are those talents who can convert the ideas of either any kind of silicon chips into any kind of idea into a silicon chip. So as an example, if you have used a USB port on your smartphone or sorry, not smartphone, on your laptop, then you are plugging a device to that to your to your PCs or your laptop. And when the data transfer happens, that is only happening because there is a silicon chip which has been designed to detect that device and then enable the secure connection and then transfer the data. So all this is called as turning your ideas into a product and then providing a solution which goes to a company, which this company then turns it into a final finished product. So this is how the industry works. It's always cycling around. There's always a market. Market can change, but the end requirement of providing your customers the required solution in form of with the help of different semiconductor companies will never change. So you can say that there's a market for automotive, where if you open your if you go and sit inside your automotive and there is a pressure sensor to check how much pressure is there in your tire. So that is happening because of a sensor which is designed by a semiconductor company and then sold to our customers, and then which is they have assembled into a car. So this is how the industry works in a very sort of a drone view, if I may say so. Then uh, let's jump into what is happening in India and where the world is. So what is happening in India and even in the world is last 4 5 years has seen a tectonic shift in how everybody looks at semiconductor, because so far majority of the focus even for the early career professional was like software is the area to be in, and that is certainly a still an area to be in. Lot of activities happening on it, but the moment the different governments realize that all the wireless data communication, all the server data storage, all the automotive electronics, all the aeroplane electronics, so any kind of massive critical infrastructure which is out there in this world is relying on, there is only one thing which is relying on is a silicon chip, and those silicon chips are actually very concentrated in terms of which countries are designing and manufacturing. And any country in this world, as we go ahead towards more digitization or more adoption of handheld devices, or maybe or advanced electronic vehicles which will require more better electronics. So there's a understanding that this all solution, whether you move from 4G to 5G to 6G, you will require a lot of silicon solution, and you just cannot be always relying on it, because usually if you look at from economics point of view, a country like India would is still, and at least until last year, was importing a lot of electronic chips, and there is a negative deficit here. So you are actually importing more than you are exporting, and any technology field you really don't want to be in a situation where you're importing more than you are exporting, and because that means you are heavily dependent on it. So because of that, and because of similar to India, there are several countries which realized, they started providing incentives. Let's understand what this industry is about. So everybody knew about silicon design, but there is also a gap of semiconductor manufacturing. So that is where government across the world started coming across with policies for academic, for universities, for industry. Let's get together. These are the funding we will provide, and let's focus on manufacturing aspect also, apart from the design of silicon chips. So that is what is going right now in India and also in other countries, where there is a lot of push to develop or have in country infrastructure. So if you look at from India point of view, India already has a lot of top tier design centers. The only thing it was only lacking in terms of semiconductor is the manufacturing. Like how do you convert a design to a finished chip without sending anything outside your country? So far, India has been relying on other countries to do that, or the companies which are there. But that is what the government and even the industry is helping, trying to change with 3 to 4 manufacturing focused units being announced in different parts of the country. And what this is going to do is this is going to increase the requirement of learning this manufacturing knowledge in university, or maybe having a very brief overview in your school, in your high school. And then some of the students will go into research part, and then some of them will join the industry, and then they will try to push the new market out. Let's say if you're going towards a Wi-Fi 7 solution, or whether you are going towards home automation, or you're going towards your even for your trains or your road safety, any kind of technical solution which is needed, you will need the required workforce to be part of it. So that's why it's important to understand what is happening in India, and where this industry is going, so that a person who is yet to blend into this industry can make a very solid judgment, if this industry is for me or not. So these are the things which are happening right now. Major focus is on manufacturing. Design was already there in India, and it is still growing, with many companies having second headquarter as a base in India in different parts, whether it is Noida, whether it is Hyderabad, whether it is Bangalore, Pune, even in Gift City in Gujarat. There are a lot of areas where companies are already present. They're increasing their presence. Now, the reason there is another angle to look at this industry is the how much economic impact it has. So if you look at from the dollars point of view, even if these number doesn't make a sense, it's just about understanding that 1 trillion is like having uh, a very huge market. Like it usually takes around 30 to 40 years to achieve that target or achieve that market base. But that is something which this industry will achieve in next 2 to 3 years only, if not by in 2 3 years, but at least by 2030. And the major growth will happen because of all the top major points I said, like the consumer electronics, your electronic smart televisions, all the electronics which goes inside this will get more advanced, so you will need more demand. So that's where there will be more requirement of uh, there will be job creation in those aspects of how we design better uh, chips for your smart television. Then there is a focus on computing and data storage, and then automotive electronics and automotive computing. To take a step back, computing and data storage is more about artificial intelligence. How do you capture your data and do the processing in a very fast manner? And then there is automotive electronics field, where whenever you drive a car, there is a lot of electronics in it, and that is also something which semiconductor industry provides. So all these verticals are going to increase, and they're already increasing because of a transformation from internal combustion engine to electronic vehicles, and then towards smartphones to better smart devices, or maybe home or different kinds of security stuff. So the all of these is a growth vertical, and to drive this growth vertical, one of the key major impetus would be the jobs which it will create. And globally it is projected there 1 million direct jobs will be created, where people either with the knowledge of semiconductor design, or with the knowledge of manufacturing, or the mix of both in terms of managerial experience, business experience, finance experience will be needed for this part. So this is why it is important to understand the economic aspect, so that one can make a sound decision about where this industry is going. So you can really see whether you see a very sort of a secure future. And in today's world, with so many things changing in the technology domain, it's difficult to say what will be there in 5 years or not. But it's a very good metrics to see where this industry is heading, where your career is heading, and whether your skill set matches to this, and how to match it to those. to the requirement of this industry. So if you look in terms of compare India to world and very broadest aspect of different technology. For example, if you go in a manufacturing unit inside a semiconductor manufacturing unit, what you would first find is a very big giant building, and then you go inside, then you will find different control room environments, and then you will find different equipments. In each equipment would be processing different kinds of wafers at a different stage. So I won't go into much details about that, but to enable those, you would at the end need all these aspects. For example, you would need equipment, heavy equipment, machinery to turn your design into a very smallest possible uh, 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 devices, which is like you can't even see with your naked eye. Those are so small. Then you would need design softwares, which are called as electronic design automation tools, to turn your ideas into workable product. Then you would need materials, let's say raw materials, chemicals for cleaning, other type of materials to drive your wafers ahead so that you can get into a finished product. Now, apart from that, you would also need to create some kind of IP, like you already has created a lot of products. So if you want to reuse those stuff and then create another next gen product. And then uh, once these are called as only mainly from the support environment from point of view, then there are companies which are fabless. Basically, they are just doing the silicon design. They don't own any semiconductor manufacturing anywhere in the world. So those companies are just designing software and then sending it out to manufacturer. And then we have integrated device manufacturer which are designing also. They can send it out for manufacturing also. They internally also have manufacturing units. So these are the companies which we call as integrated device manufacturers. And apart from my company, which is NXP, there's one more company called as Intel and another company, Texas Instrument. These are all called as IDMs because they have both in-house and an external manufacturing capability, apart from design. Then there is something called as pure play foundries. Pure play foundries means they only do fabrication. They don't do design, they don't do packaging, they don't do assembling. So assembling packaging is a very different topic than fabrication. But there are companies like Taiwan Semiconductor Manufacturing Corporation. Then there's the newly announced Tata uh, uh, I think PSMC, which is going to set up their manufacturing in India. So those will be called as only pure play foundries. They won't be designing product. They will be allowing you to turn your design into manufacturable products. Now, apart from fabrication, you also have to know every chip you send out in the market, any silicon chip you design, there will be always going to be a specific package inside which it will go, which is called as assembly. Then you send that package to a testing house to test exactly whether all the functionality is working as correctly or not. So uh, now the reason I slowed this slide is not just this data is from McKinsey and Company, and is not just because it clears breakdown of different components of the semiconductor world or the ecosystem, but it also says that India is yet to get into this as a dominating force. Because if you look at any section, there's the dominance of rest of the world includes other countries also is very less. And even if in terms of materials, you will see that it's the Japan which is ahead, or if the not Southern American countries which are ahead in terms of providing raw materials. So there is a push to change this data, and this data will only change if you have more product development, product focused approach. And for that, you definitely need manufacturing in-house so that you can bring more ideas out of your design companies and turn it into a product by utilizing all in-house in-country units. So this is the push which is going, and this also presents a massive opportunity for students who will be part of this transition, because India would need a lot of trained force for this, and this is where you connect the dot of what your skills you have and where this industry is going, where India is trying to transition, and then create an opportunity for yourself, and then also push this industry forward in India. Now, as I said in many times, that the productization, turning your design into a product is the ultimate goal of the semiconductor industry, and does not matter whether you are doing only fabrication, assembly, or testing. Eventually, you are trying to turn your ideas into product. An idea could be a very simple 555 chip, or it can be a processor, or it can be a Wi-Fi chip, or it can be a CMOS sensor for your camera. So all these can be turned into a product only with focused approach of productization. That is what we call turning ideas into silicon products. And this is what I call as a semiconductor wheel. And it's already a very detailed view of what I already explained. So I will briefly go over it again to not repeat myself here. But Fabless are those companies which just do chip designing. Pure play foundries, they only do manufacturing for their customers. Integrated device manufacturing, they have mix of both design and manufacturing. Outsource semiconductor assembly and testing is something which you use to do only assembling and testing, not for fabrication. So if I am a fabless company, I will design my silicon, I will design my intellectual properties. I will send those files to POP foundry because I don't have anything inside to manufacture, and then they or I can also send it to IDMs if they have a fabrication unit which they outsource. And then I will move that product, turn that idea into a wafer form. Wafer will have all the imprints of repeated design files of my idea turned into a at the wafer level. And then I will send it to an assembly and testing house, which will assemble, package, and then they will test it. Now, to do all this, there will be support companies like raw material equipment, which I already said. So to turn any product, you already start with an R&D phase where you design exactly how to package your solution, what exactly you want to focus on, and what is your target uh, market. And then you start gathering all the information regarding raw materials, which equipment we will need, are those equipment available in the fab? 99% yes, but sometimes you are pushing the boundaries, so you might have to tie up with them to get those new equipments. Then you are checking your IP tools. Then you're going into the designing phase where you have different kinds of engineers. You have analog engineers who only work with circuit level just for simplicity. Digital designer who have more in work knowledge about state machines, or how to work with memories, or how to work with different timing related designs. Then there is a verification team which is also checking if everything which is designed is correctly designed or not. So similarly, there are different roles within the design phase. And then you pack your design, you send it to a fab. Fab goes through, send it to assembly. You send it to your end customer. So PCB would be like a company like Foxconn, which would take your different chips from different vendors and then turn it into a assemble. And assembling is what has been happening in India for a long time. As a very good example would be Dell. Dell has been selling laptops in India for almost 3 decades, if I'm correct, and they have a lot very good assembling facility. And what they do is they take chips from different vendors, they create their own motherboard, and then they assemble it. And that is happening in India, and that is happening in India with all the smartphones also. But now this focus is, not don't just do the assembly or by taking the components out of or importing the components. Instead, do the designing everything inside India and do the manufacturing, and then you will have 100% control, and you also don't lose out on those export import deficit which I was talking about earlier. So this is how this wheels turn for every product. So every product goes through this phase. And just to give you an idea, in last year, semiconductor industry shipped close to trillion units, trillion silicon chips. And if you convert into product level, because you can have trillion will have different types, same product will have multiple consumption. So you will have at least 100,000 to half a or more type of different products which are being which have been designed, which are being enhanced or ported to a next generation. So there's always a continuous wheel which is going on in terms of product development. And one of the critical reason it goes on is because of the talent needed. And that is where students come into picture, from whether you're only focused on designing, whether you're taking your courses in VLSI, whether you're taking courses on your reliability study, which is not related to design. And so this is how you try to look at this particular picture and then see how you can, match your knowledge to that requirement of the market. And this is just a very quick overview of how the ingot which I was talking about turns into wafer, and then goes to different equipments in a fab. So any fab you go, any fab, if you ever get a chance, or even in labs in different IITs, or even in semiconductor laboratory in Chandigarh, which is managed by ISRO. If you go, you will see different sections and different equipments. So each of these equipments is actually itself $1 million market, because not every company designs it. So some would be only focused on deposition stage, where you're putting a material on top of wafer. Then you're trying to do lithography, where you're trying to make some patterns on your wafers. And that's the reason where silicon comes into picture, where you can expose and then adjust your light such that it can transform into a specific device shape. And then you start doing different process steps, let's say etching, cleaning, forming interconnect. Interconnect formation is the way I like to explain is when you're building an apartment, so you're building one floor at a time. So silicon chips is same. You are building an high-rise apartment with pillars connected to it, but you are making it a very, 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 very small level. So that's how complex this process becomes. And then, as I explained, testing, packaging happens, and then different devices go into the smartphones. So the reason to show this slide is not to explain you what steps are involved. The reason to show is that if you're a student and if you're good at understanding everything about deposition in terms of equipment or the technical aspect, then you can have your career only in deposition field. Usually, if you're in a fab, you don't see that somebody who is working on lithography is also working on etching, is also working on cleaning process. No, it's usually a section of people who are working on lithography because they only have the skill set and knowledge to do that. So that's how you should be. This is the good way to look at only the manufacturing aspect, where you can pick and understand, which area I should be focusing on, and which part I can be, what skills are needed for that particular process step, and how I can be part of it. So if you want to learn more about lithography, you will have to learn about ultraviolet rays. You'll have to learn about photonics. You will have to learn about different tools to use it. So this is how you design your, future requirements, and then try to enhance your skills by learning those steps. And same way, if you're somebody who is not much into, I don't want to work on wafers, I want to work on end product, then and not on swan designs, and then packaging is something you can work on, because packaging is a field which requires mechanical engineer, it requires electrical engineers, it requires electronics engineer, computer engineers, because there are subdivisions within those which need different skill set. So if you're somebody who has done mechanical engineering, then you would be more versed in doing the simulation, CAD analysis, and those. If you're somebody who has done electronics engineering, then you can be very good asset in terms of doing different kind of simulation study or projection study or aging simulation study, or understanding how the material impact would be. So those are the kinds of study or work you do. So this is how a student can always look into the industry and try to understand within manufacturing of semiconductors what are the process steps, and within that process step, is there an isolated area I can be part of, and what are the skills that needed. So this is just an overview of that. And just to give another view of what it takes to turn a silicon chip into an end product. So if you take as an example, this is a very good infographic from Quarter. It's a finance-based company. It did the analysis of how Apple's phone was developed, and then it opened it up and looked into different chips. So you can see it has name of different suppliers which are providing chips, and each of the suppliers going through this cycle where they are capturing the customer requirement, putting the business case, they are working on the budgeting, they're translating it into design, they're verifying the designing, and putting it through all manufacturing process before it ends up in customer hand. So it's not just like only one company in the world is doing it, right? So there are almost more than 50, 60 different types of companies doing it, or maybe 100 companies are doing it. And then there are emerging startup companies which are doing it. So the amount of opportunity which opens up for any new student who is graduating and trying to enter the workforce is massive. Agree. There is a level which is expected out of industry, which they expect in terms of skills, or even in terms of prior little bit of experience they might want. It's in terms of project or internship, but that is always part of any competitive or any a matured industry like semiconductor. But the thing is here, there is not one specific isolated area where you said, oh, this is not for me. But if you're a student who wants to look at this industry in different manner, also try to look that if you are using a spoon, you are using because only not just one company worked on it. There are 100 companies which came together to work on it, right? So there are so many opportunities there. So you can try to look into whether you need firmware. If you're good at coding, you can be a firmware engineer in this field. If you're good at digital designing, or you're good at circuit level analysis, you can be a analog analog simulation engineer, or you can be an analog designer. So that is how I would suggest to do a view of this industry and what it takes to enter it. Now, this is a very different take from my side. It's a combination of school. School means your high school and pre-high school area zone, and then you graduate, and then what you do. So, we all go to school. We all have been to school for different reasons, but the focus ultimately is, to develop, to learn, and in the long term, create skills at that particular level so that you can turn it into your long-term career. Now, whether you're doing a business or you're just doing a job, whatever it may be. And if traditionally, at least the schooling system I went to, you do your grade 10, you do 10th, you do your 12th, and you appear for exams. And in 10th only, you get to choose different streams, let's say arts, commerce, and science. But one thing which stays even after your 12th graduate, and which you realize in your first year of engineering, is that you're still learning some courses on mathematics, some courses on physics, and some courses on chemistry. At least I had to appear for courses on this. So the part towards semiconductor is not, starts at undergrad level. It actually can start at school level. And that is what many of the countries are also right now doing. And slowly it's picking up in India also. So if you look in terms of, as an example, in US, what happens is there's a journal called the Journal of Emerging and Investors, and what they do is they try to work with high school students and they publish papers, not very high grade papers, but at the level where a school student can do some kind of coding, they can transform some data or they can transform some ideas into a solution. So this is how a journey of any somebody who is in a early stage or in a secondary school can try to march toward this. This is slightly higher ask, but it's also not something which is not doable, because a conference like JEI is not expecting you to be very thorough in research. It's just about focusing and providing a view of different topics, and this is how you can also learn, or a student can learn about the semiconductor industry while being in a school, as long as the goal is to just to give an overview, not to force somebody to take this field. Now, let's transition from school to graduate. Undergraduate, as I see it, is all about three things with the ultimate goal. Now, what we do in undergraduate in your, whether you are doing a ETC, ENTC, or EE electrical engineering, it's all about gathering all the knowledge. And it's very important to gather the right knowledge when it comes to semiconductor, whether you are having your basics correct regarding how a transistor works, whether you have your basics regarding how the data is used, whether you are very good at circuit level analysis or circuit level designing, or whether you're good at embedded system, firmware engineering, and all those stuff. So it's all the years you spend on undergraduates all about knowledge. But the gap which I see personally is on the responsibilities and skills. Responsibilities is not from your personal point of view. It's about the what the market needs, what the market is asking you from when you want to join that workforce, that what are the responsibilities I would have when I join your company. So this is where the knowledge gaps come into picture, and this is where ideally a student should focus on, because knowledge anyhow you are going to get in your 3 year or 4 year of undergrad degree. But responsibilities is something you need to understand in terms of market requirement. And that is, well, because the more important reason is because you can harness your skills accordingly. So company is, if a company is asking, I need industrial engineering students. So what do industrial engineering students require, what work would they do, and whether they it's just about data analytics, or it's about equipment handling, which type of equipments. So those are the kind of pre-skills. Nobody is expecting you to be 100% thorough in those skills, but the at least the basic requirement is you understand what the market needs, so that at least you can be appear either it's your interview or your internship. You can try to prep yourself for those, and then the ultimate goal is nothing but to do job or career or business out of it. So it's very important to understand that knowledge you will get in your 4 years of degree or your 2 years of post graduation, but it's very important to understand what responsibility and skills are. So to give an overview, what I have done is I've gathered this table. I won't go through details of each and every, but just to take an example about, if you are somebody like me who sees an opportunity in product engineering, and it's very difficult to say that you are liking X field or Y field, but you can at least look into which skills are needed. You need to have some good knowledge about yield, design of experiment, quality stuff. What is quality in terms of silicon chips? What is testing, operational reliability, characterization? What is characterization in terms of product development? And what are your responsibilities, right? So once you know about the skills and responsibility, then you can better understand which function you are suitable for, because it never happens that you have all the skills. You can be responsible for all those skills which get transformed into specific function type or roles, and then you can join the company. It never happens like that. So this is another good way to understand, which functions are there, which types of jobs are there in semiconductor industry. Like there are different types of role. Like I have three, four slides on it. As an example, equipment engineer, you would be working on equipment designing, maintenance, electronic drawings. If you are a fab automation, if you want to join a fab automation packaging assembly, do you understand fabrication processes, issues, yield, chemical handling, what chemicals are used? So all those stuff you would have to have knowledge about. Package engineer would need to know, it need to have the skills about packaging technology, assembly process, and they would be responsible for maintaining silicon chips or protecting them from the external harm, let's say physical or thermal and all those stuff. So this is a very broader view, but the goal here is to show that there are different types of functions. 99% of the students I interact with are often focused on analog and digital, and it's very the major reason is because it's a high paying job, and if you have the right skill, you can be in a top 1 to 5% for the company you're joining, or for the even for the industry if you have right skills. But there are other functions also which require different roles, and engineering students from electronics, electronic communication, electrical engineering, even fields like mechanical can be part of this. Then how do you decide? So far I have already given a lot of information, different viewpoints you can use, but eventually it's all about connecting the knowledge, skills, and responsibilities, or responsibilities, you can call it. It's about identifying which skills you have, which skills you're really good at, and trying to match it to the function which the industry provides. So basically trying to see if you are really good at coding. I would not go anywhere apart from embedded system and firmware engineering. These are the two functions only you can be part of if you want to join semiconductor. There are data related software, but you really don't want to be part of those if you're joining semiconductor. But there are still opportunities in data mining, data aggregation, data characterization, and all those stuff. But as such, there is no shortage of different roles. So this is how I would approach if I was at your place, and if there are students who are attending who are in their first year, second year of undergrad, or even in their high school, they would like to understand the requirements the way I have said in the last few slides, and then convert into your specific target. And this is another view. This data is not coming from me. This is coming from uh, there's a semiconductor research corporation in US which does a lot of studies in collaboration with US government, US industries, and all those academic researchers who are into this. So they came up with a very nice flow where they said, there are different functions, and then there are skills and which skills are in a critical area. So this is another way to look at it. If you already know you want to join this semiconductor industry, irrespective of what it is, try to harness your skills in a domain where it is critical need. Because if there is a critical need and you are the right person, then you are always ahead of the game, because then you would be always in demand until that doesn't become very uh, flooded domain where a lot of people are coming, a lot of students are joining it. But there are a lot of requirements. Let's say test engineers. Test engineers, what they do, they are very critical for your product development. The moment you get the silicon chip out, before the mass production, you have to test it for different specification. I don't know if how many of you have read datasheet, but if you go and read datasheet, it's all about making sure everything written in that datasheet matches with what the chip is providing. That is where test engineers come into picture, and then they work with different teams. And even product engineer, which I do, is a critical role where you need to understand different device level functionality, different simulation stuff, different product requirement, and the understanding data, which is a very critical part of product engineering. So this is another way to understand. There's so many roles, and then if you get confused ever, you can go back to this. You just need to Google SRC MAPT, and this should be the first link on Google that will tell you where this chart is. And then this is how the system will be. If you end up being a semiconductor engineer, you would be in this ecosystem. So somebody on Twitter posted this, and then I referenced this on my slide, where you would be either doing only designing, you would be either doing manufacturing or joining one of these companies, or you can even be joining some large software companies like Google, Microsoft, Meta, who are also doing a lot of silicon chip development, who need silicon semiconductor engineers. And then you would have only IP companies which will be providing different IP blocks for this particular solution. For example, if you're developing USB solution, then you would be having IPs for USBs or some kind of memories from these companies. And then there are companies which are integrated design manufacturer, which will be combining all this design and manufacturing in-house. So eventually, if you end up being part of this industry, you would be getting divided into this kind of classification, whether you work on design or manufacturing company. But the ultimate goal is there is endless opportunities, endless companies which are looking for talent, and it's all about how you match your requirement to match your skills to the requirement of the market. So this is where I will end my slide. So if anybody has any question, I can answer those, Rohit.
So I will just certainly check this. Just a moment.
Yeah.
So one question that I would like to read out to you. So the question says that as an undergraduate, can I enter into the industry without going for masters?
Yes, this is possibility, and there are a lot of people who do that. But eventually, what ends up happening is after you join the industry and you see the amount of time it is taking to bridge the gap, you either get inspired or you eventually get mentored to do masters. It's not that master is a requirement, but as an undergrad also you can join. But you would see that depending upon your skill set, you might not be getting the initial responsibilities in terms of project execution, which either a master's student would have. And the reason is because they would be having much better skills in terms of project execution of technical aspects. But I won't say it's a hard requirement, but it is something which would push you ahead in terms of course, from salary point of view, but also in terms of responsibilities which you will get while working on a different project.
So one question that I would like to ask that you just highlighted.
Yeah.
So it is like as our students get placed and all, so there's always a competition between EC and computer science domain. right? And people are
Yeah.
more, uh, going like liking towards the computer science domain because of the programming that is involved, right? So
Yes.
coming to our ECE, like as you said also in your presentation, that embedded system is one of the domain. But other than that, do we have programming that can engage our students?
Yes. So there is something called as firmware engineering, but it's not so embedded systems. I would say is a two-part. One is like you are only working on an end product with a development board and then enabling some solution, like writing a device driver or something like that. But when we develop silicon chips, there are chips which we need smart, small or very tiny boot up software code. So that is where there are coding skills which are coming into picture, but not necessarily here also. When somebody is good at, let's say, I would say Python, Perl, or any kind of scripting languages, then they can also be a digital verification engineer and also be an analog and mixed signal verification, which are very core design profile, but they also need coding because they all have to write models, they have to develop different solutions. And then apart from this, there are also different, uh, I would say, CAD related solution which you develop. And for that also you would need people who are good at electronics. So you might not be working directly on silicon design, but you might be working on a software tool for an electronic design company where your knowledge about ECE plus your coding will come into picture because you're designing a tool or a feature for that particular product. So there are certainly different ways you can use your skills in if you have a coding skill plus you have electronics knowledge or your background knowledge in terms of transistors or different process steps.
Okay. So one more question is there's a last one. Sorry
Yeah.
to engage you. So
No,
the
no
thing
worries.
is, the question is regarding the pay disparity. It says
Mm.
that when we compare a timeline of 10 to 15 years, uh,
Mm.
the pay scales of electronics engineer and then computer science engineer graduate, then within that 10-15 years of span, when they work for their respective industries, who is better off, ECE or CSC?
So as of today, it depends upon the mark. It depends upon the geography also. So if I compare in terms of if you look at from US point of view, there is not much of a gap in terms of pay parity, pay for EC versus CSE. There is a gap if you are working in India or if you're working in some other countries. But it certainly the computer science is slightly ahead because of all the faster solution software deployments, and there are a lot of companies which are using the requirements. But in that ECAC also, people usually students get you know they should follow the right path in terms of knowing that in CAC, not everybody get handsome pay. Only those which have the right skills or are very good at programming or developing software get a very high pay. So in the long term, it evens out. But in the early career, you would see that CAC is having a slightly edge. But I won't suggest to look in that terms because it's also about you know uh, l- taking at the long term view of how complex that industry is, what other opportunities are there, because in electronics you always have an option to switch from one role to another as long as you can learn those skills. So once you're part of a company, you're doing designing one day, 5 year down the line you can do some other type of stuff which is, let's say, post silicon validation or post silicon analysis. So there's a lot of option also if you look at in that term. So a short answer is CSE is ahead, but in the long term it evens out. And in India also, if you have the right skills, you would get paid for accordingly if you crack the interview or on the job call.
Okay. So one query, sir, is the biggest infrastructure challenges that India faces in becoming global semiconductor hub? How
Hmm.
can we address
So,
this?
so India is already working on it. For example, we if everything goes as planned, in 2 years we will have fabrication unit in Gujarat, right? We will have assembling and testing companies in one in the Northeast area and one in Gujarat, another one in Gujarat. So the bottlenecks are already being solved. So it will just take time. Like right now, we cannot say that we are fabricating and manufacturing, assembling, and testing, but it will start happening over. Let's say next year, you would be in a better position, and if the project execution goes as planned, then by end of 26, there will be a dedicated manufacturing house. And just to give an overview for those manufacturing units, even one from Micron Technology, which is already 20-30% done. The hiring has already started, right? So if you are a student who is in your second, third year, I would suggest to start looking into roles which are being posted online from these companies which are looking for talent to join now, so that they can either train you outside India, then bring you back, and then they can train you in your R&D center in India, and then put you to the manufacturing unit. So that gap would take for a long term, it will take a lot of like 10-15 years, but short term we would have in-country manufacturing in within 2 to 3 years.
Okay. So the last question, sir. How prepared is
Yeah.
India to adopt and manufacture advanced semiconductor technologies like 5 nanometers and below?
Yeah. So right now it is not, because there's only two companies which are doing this in the world. So I won't say India is prepared yet, and India need not be even prepared, because the requirements are very different. Not every product needs that silicon node solution. So right now India is not prepared. India is focusing on 28 nanometer homegrown solution, and then it will move towards, as per the market need. For example, to give you a stat, India is like third or fourth largest manufacturer of automotive. So India would rather focus on providing silicon chip with a specific node for that market, rather than going for a very ultra advanced 5 nanometer, 3 nanometer, and 2 nanometer. So it's not about prepare, it's about the market economics also. And even if in India, even if there are companies which will go there ultimately after they have set up their first couple of nanometer fabs on the mature node only, less than 40 nanometer, but larger than 20 nanometer, they will take a lot of time, and it will be very difficult to go there unless a company like TSMC says we are going to come and set up manufacturing in India. Then there will be a leap jump. But the probability of that happening as of today is low. India, it's not about whether India is prepared. India does have a lot of right set of research and right set of research skills, and all right sets of workforce skill. It's just about that the economics of doing that doesn't is not suitable right now for India's requirement.
Okay, thank you, sir. Thank you for answering, sir, so many questions
Yeah,
from our
yeah, no problem.
participants, and really
Yeah,
very informative session. The data that you have shown, I believe, would definitely inspire our students and help them in finalizing what domain they want to choose, because you are given
yeah,
full explanation and supported with data. So I really thank you
yeah,
for spending some time with us, sharing your knowledge and inputs. And sorry for the delay that happened in between.
yeah.
And
No,
that's
no
all from my
problem. I
side.
understand.
Thank you very much.
Yeah, yeah. Thank you, Rohit sir. Thank you to everybody who joined. And I'm always available if you want to reach out to me after this. I have my own personal website, and if you want to connect me on any social media platform, happy to connect and then ask any question, and I will try my best to answer. So thanks. I will end this
Thank you.
presentation.
Thank you, sir.
Thank you.
Yes, sir. Thank you very much, sir.
Thank you. Bye.